Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for September 13th of 2025 is titled Star Trails over 1 Mile Radio Telescope. So what do we see here? Well, in the foreground we see a radio telescope, and this has about a 60-foot diameter mirror and is used to observe the sky at radio wavelengths. Now, that gives us a different perspective on the sky because radio waves are emitted by different types of objects than typical visible light. In general, visible light is emitted by hot objects. Things like stars are thousands of degrees in temperature. Radio waves are often emitted by very cool objects, so it allows us to see some of the cold dust in the universe and track things that would not be visible, not be emitting specifically visible light. Now, this was the first radio telescope to use a technique known as aperture synthesis, which is a way of looking at different signals from the telescope. And in this case, as the telescope moved around, then you could use that to get different images of the sky at radio wavelengths, combine them together to enhance the resolution to see how much detail you could see. Now, that's important because radio telescopes, because of the long wavelength of radio waves, have very poor resolution. They can't separate fine details or locate things precisely in the sky. So, using this technique has been able to give much better resolution for radio telescopes. Now, as I mentioned, it's the rotation of Earth that helps the radio telescope in this case in the early days of aperture synthesis. It's also the rotation of Earth that gives us the pattern that we see in the sky, the star trails. Now, the star trails that we see here are a number of 30-second exposures. So it's not one single exposure. There were 30 seconds combined over a period of 90 minutes and then put together to give us the star trails that we see. Now, those are caused by the rotation of Earth. So Earth is rotating, and that makes the stars appear to move. And the point at which they appear to revolve around is the North Celestial Pole, and you can see that as the point at this up towards the upper left-hand side where everything seems to be swirling around. The relatively bright star near the center of that region would be the star Polaris, the North Star. It is not located precisely at the pole, but is relatively close and helps to identify the location of the pole for observers in the northern hemisphere. The farther away you get from the pole, the larger the circle will be, and that means that there are some stars that make complete circles around this pole and never actually cross the horizon. Those are stars that never rise or set and are called circumpolar stars. Stars farther away will make much larger arcs in the sky and will cross the horizon, rising and setting. And if you go far enough south, there will be a set of stars that you could never see from that specific location because they are too close to the south celestial pole, which is not visible to observers in the northern hemisphere, which is where this image was taken. So that was our picture of the day for September 13th of 2025. It was titled Star Trails over 1 Mile Radio Telescope. We'll be back again tomorrow for the next picture, previewed to be Tilts and Spins. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.